For this bench simulation, we are using the values A and B as two 4-bit inputs. A is represented by the binary number of 5, and B is represented by the binary number of 11. And then our selector is 0 currently, and our output is 0. So when we first run the simulation and we get a 0 as our our input from the selector, our output we expect to be 0, 0, 0, 0, and this is because 5 plus 11 is 16. 16 in binary is 1, 0, 0, 0, 0. But because we're only allotted 4 bits, the 1 is taken off of the beginning of the binary number. Then it establishes that these are our numbers used. When 0, 1 is inputted by the selector, our output is expected to be 0, 0, 0, 1. And that is because when you select 0, 1, that is using the AND operation. And as you can see, there's only one case where the ones are both in the same place. So these two are being compared and will result in a 1, while these 3 right here will not be result in a 1 because there are zeros. And that's how the AND operation works. So once we step through it, if you have a select input value of 1, 0, which is 2 in binary, then it ORs the two values. And so if there is a 1 in any place, then it's going to be a 1, and that's how the OR operation works. So because there is a 1 in each place, the answer expected is a 1, 1, 1, 1. Stepping through, you're going to get, if you NAND them together, you're expected to get 1, 1, 1, 0. And that's just coming from NANDing these two numbers together. So if you AND them, they are going to be a 1, and if you negate that AND, it's going to be a 0. And so it's basically the opposite of the first selection. And then we're going to step through it. And then we just know if you just do 0, this is going to be your sum.